Assalamualaikum and greetings. I bid to our respected lecturer, T.S. Dr. Muhammad Norhisyam bin Razali alias Ghazali. We are from Group 6 and in this video, we are going to discuss about our WEKA group project titled Inventory and Stocks Management Analysis for Rahna Garments Boutique. The group members consist of Altira, Faliona, Siti, Shazriatul, Afieza and me myself, Siti, Rohadatul, Aisy. Now, let's get right into it. We will be further discussing about the introduction, problem statement, methodology, data understanding, summary of machine learning models or MML, summary of a priori model rankers, summary trend analysis plots, recommendations, as well as the conclusion. Businesses need smart ways to track stock so they run smoothly, save money, and keep customers happy. For a small and medium businesses like those in fashion and tailoring, and keep accurate stock records is the key to stay profitable. Rahna Garments is an established boutique in Mekah, Sarawak, run by Rahna Buhari for about 7 years in the industry. They sell traditional Malaysian attire like baju kurung, jubah, baju Melayu, tudong, and many more to customers across Malaysia, including from Kuala Lumpur, Sabah, Labuan, Kuching, and Miri. However, they only manage inventory manually with handwritten notes which rely on owner experience rather than data. This causes problems like overstocking, slow movers, and stock outs. Such problems they face lead to big issues such as stock shortages. During festivals, popular items like dresses or fabrics sell out fast. No past data means that they cannot predict and restock in time, which lose sales and frustrating customers. Following by overstock, like slow-selling designs pile up, lying up money in storage. Manual notes don't show long-term trends, so spotting weak items take too long. Then seasonal ups and downs. Sales spike during holidays, school breaks, or fashion trends. However, they could not also plan properly for it. These problems mean wrong buying choices, high storage cost, and wasted time by making the business less efficient. The objectives are to implement machine learning, or known as ML, procedures using WEKA for processing inventory and stock performance data and enable evidence-based decisions. For instance, we analyze data with WEKA by converting unstructured business data into a structured format ready for ML. Then, we test the ML models by comparing them on classification accuracy and building a decision tree to guide inventory choices. Next, by identifying key features impacting stock performance through targeted feature selection methods. And finally, by examining trends in key features to uncover relationships and recommend practical action for better inventory and stock management. Our methodology follows a systematic data mining approach by using WEKA. First, we digitize Rahna's handwritten logbook into Excel, then clean duplicates and inconsistency, following by converting it into ARFF format for WEKA compatibility. Next, we applied the 6 interpretable classifiers such as decision table, JRIP, 1R, part, 0R, and J48 decision tree to predict stock levels from high, medium, or low demand. The a priori algorithm uncovered association rules linking product categories with suppliers and demand patterns. Info gain and correlation evaluators rank the most predictive attributes. Finally, WEKA's visualization tools generated trend plots and model performances metrics, which delivers a clear, actionable business insights for optimized inventory decisions. Moving on to the next part, as we can see from the figure in the slide of all attributes, this shows full data in pre-processing stage, which means we examine every detail to understand the stock patterns at Rahna's Garments. The seasonality, which is shown the years and months of uneven activity, such as busy peaks and quiet periods. This points to seasonal shifts in demands, like festivals or holidays driving more sales. The supplier reliance is one main supplier dominates, with other used less often. So the shop depends heavily on this key partner for most products. The product types and sizes vary, but popular ones and standard sizes sells the most. So this confirms on focus to what customers want the most. The restock amounts stay mostly low to medium, with one level used often. This suggests a steady, predictable approach to refilling stocks. The selling prices also cluster in an affordable and mid-range options, which matches with what most buyers prefer. The top categories of 7s exist with full data coverage, such as women's clothing leads, followed by men's clothing and fabrics, and others appear less often. I will now pass to the next segment to the next presenter.
To evaluate the effectiveness of machine learning techniques for inventory analysis, several classification models were tested using WEKA. The selected models include decision table, GRIP, 1R, PAT, 0R, and also J48 decision tree. The restock quantity level was defined as the class attribute and categorized into high, medium, and low demand levels to support classification using role-based and decision tree models in WEKA. First model, decision table, shows accuracy of 99.61%. Second model, GRIP, shows the accuracy 99.52%. The third model, 1R, shows accuracy of 100%. Following the fourth model, which is PAT, also show 100% of accuracy. And the last model is for rules, which is 0R, shows accuracy 74.43%. And the last model, which is 3J48, shows the accuracy of 84.39%. Overall, the results show that most of the selected models perform extremely well. This tells us that the dataset contains strong and consistent patterns, especially related to quantity of restock and product characteristics. These attributes allow role-based models to learn demand behavior effectively and generate accurate prediction. So, this level of accuracy gives high confidence that the models can support reliable decision-making in inventory, planning and determining optimal stock levels, and reducing unnecessary overstock or shortage. In practical terms, an accuracy above 99% means the system can consistently distinguish between high, medium, and low demand categories, which is crucial for retail inventory management. So, this makes the role-based models particularly valuable for operational planning and Rahna garments. However, not all models perform equally well. The 0R model achieved only 74.42% accuracy, which is classified as moderate. This outcome is expected because 0R does not learn from the data. Instead, it simply predicts the most frequent class, which in this case is high demand. As a result, it fails to recognize variation in medium and low demand, making it unsuitable for real decision making. Nevertheless, 0R serves as a useful to compare to the effectiveness of more advanced model. Meanwhile, the J48 decision tree achieved 84.38% accuracy, which falls under the good category. The model successfully captured meaningful relationship between product attributes and destocking behavior. However, its accuracy was slightly lower compared to the role-based classifiers. This may be due to the complexity of the decision tree structure and overlapping attribute values, which can introduce minor classification errors. So, in conclusion, the findings clearly indicate that the role-based classifier, especially 1R and PAT, are the most suitable models for this dataset. They provide excellent accuracy, consistent prediction, and easy interpretability, making them highly practical for supporting inventory analysis and destocking decision in Rahna garment.
Next, I will explain the findings from the WEKA attribute selection using the infogain evaluation with 10-fold cross-validation. The dataset contains 1,044 instances and 9 attributes related to inventory and sales. The purpose of this analysis is to identify which attributes are most important in predicting the restock quantity level. Based on the result, the most influential attribute is quantity restock, which achieved the highest average merit score and ranked first. This indicates that the amount of stock being replenished has the strongest relationship with the restock decision. The second most important attribute is product type, followed by selling price and product category. This suggests that different types of products, their pricing, and their categories significantly affect how inventory should be managed. Next, product size and product brand or supplier show moderate influence on restocking decisions, meaning they contribute useful information but are not as critical as the top attributes. Finally, months and years are ranked the lowest, indicating that time-related attributes have minimal impact in this dataset compared to product and stock-related factors. Overall, this analysis shows that restocking decisions for Rahna garments are driven more by product characteristic and stock quantity rather than time, which supports the effectiveness of using data-driven features for predictive inventory management. Next, attribute selection was performed using correlation attribute evaluation with the ranker method, evaluated using 10-fold cross-validation on 1,044 instances and 9 attributes. The findings show that quantity restock is the most influential attribute, with the highest average merit of 0.281 and a consistent average rank of 1 across all folds. This indicates a strong correlation between restock quantity and the target variable, making it the most significant factor in the dataset. The second most important attribute is product brand or supplier, with an average merit of 0.155, followed by product category and product size, which show moderate influence with merits around 0.13. This suggests that product characteristics play a meaningful role in explaining the outcome. Product type and selling price rank in the middle, indicating some relevance but less influence compared to restock quantity and brand. Lastly, years and months have the lowest merits, below 0.04, showing minimal contribution to the model. This implies that time-related factors are less significant in this dataset. In conclusion, the results highlight that inventory-related and product-specific attributes are far more important than temporal factors for this analysis.
For trend analysis plot, I will focus on 4 key analyses that give the clearest insight for inventory and restocking decision. This slide helps explain when demand usually increases, what products sell the most, how pricing affects buying behavior, and which product category drives the business. Let's start by looking at restocking trend by months. Overall, we can see that demand exists throughout the year, but it's not evenly spread. There are clear peaks in March, May, August, and December. These months usually line up with festive seasons, school holiday, or major promotion when customers tend to shop more. What this means for the business is that restocking should not be done at the last minute. Stock level need to be increased earlier before these peak months arrive. By planning ahead, Rahna Garments can avoid running out of popular items and make sure sales opportunity during high demand period are fully captured. Next, let's look at demand based on product type. From the chart, it's clear that core clothing items such as fabric, jubah, kurung, and bawal consistently fall into the high demand category. On the other hand, accessory and more niche items tend to move much slower. This suggests that customers mainly come to Rahna Garments for essential clothing rather than add-on product. So from an inventory point of view, it makes sense to prioritize these core items that when restocking. Niche product can still be offered but in small quantity. So capital and storage space are not tied up in items that take longer to sell. Moving on, let's examine how selling price affect restocking demands. Lower price items clearly appear more often on the higher demand category, which shows that customers tend to buy affordable product more frequently. Mid-price items still perform reasonably well, but higher price products are restocked less often because they move more slowly. This pattern tells us that price plays an important role in customer decision making. For the business, this means affordable products should always be well stocked as they drive volume and regular sales. Higher priced items can still be offered, but they should be monitored closely to avoid excess stock and cash being tied up for too long. Finally, let's look at demand by product category. Women's clothing clearly dominate high demand restocking, followed by men's clothing. Other categories such as accessory, innerwear, and telecom mostly fall under medium or low demand. This shows that women's clothing is the main driver of sales for Rahna Garments. Because of that, inventory planning and promotion should mainly focus on this category. At the same time, other categories can be stocked more carefully based on actual demands rather than assumptions.
Now I will move to the recommendation for Rahna Garments. Based on our analysis, the business is still relying heavily on manual handwritten records, which limits efficiency and growth. Therefore, we propose 3 key improvements. First is the implementation of centralized digital inventory system. This means replacing paper logbooks with a cloud-based dashboard. With this system, the owner can instantly see stock level across all sizes, colors, and categories. It also reduces human errors, ensures all data is in one place, and helps identify dead inventory early, which protects the business capital. Second is the adoption of predictive demand forecasting. Instead of relying only on experience, the business can use historical sales data and machine learning to understand customer patterns. This allows Rahna Garments to move from a reactive approach to a proactive approach where they prepare stock before peak seasons such as Hari Raya. Third is the integration of automated record reorder points. The system can set minimum stock level and automatically alert the owner when it is time to replenish. This reduces the need for constant manual checking, prevents stockouts, ensures popular items are always available, and helps maintain customer trust and loyalty. Overall, these recommendations help to modernize the business and support long-term growth. To conclude, this project clearly shows that Rahna Garment's current manual inventory system limits operational efficiency, scalability, and its ability to meet customer demand. Through our study, we applied machine learning techniques using WEKA, including rule-based classifiers such as 1R and PART. The results show highly accurate stock restocking prediction within our dataset, which proves that data-driven methods can effectively support better decision-making. By transitioning from a reactive business model to a proactive, data-driven approach, Rahna Garments can replace manual logbooks with digital inventory system. This transformation will help optimize stock levels, reduce human errors, and allow the business to respond more effectively to seasonal demand and changing market conditions. Overall, adopting data-driven insights position Rahna Garments for sustainable growth, stronger competitiveness, and improved profitability in the dynamic retail environment.
Thank you.